Hi students, a very warm welcome to you all to the chemistry sessions. So I hope everybody is doing great and you are maintaining your revision, right? So as I told you that whenever we are discussing about some kind of a named reaction, so you need to note it down somewhere in a booklet that you might have maintained. As I told you that there must be a booklet which is maintained and you need to read it out every now and then, right? Whenever you get time, like on daily basis, for 15 minutes you have to take out time and read all those named reactions. That will really be helping you in your examinations, I am assuring you that, right? So what we were discussing in the last session, we had started off with the preparation of aldehydes and ketones, right? But in those preparations, I had told you one particular reaction giving both aldehyde as well as the ketone. But as I told you that there are specific reactions as well for just specifically the aldehydes or just specifically the ketones, right? So we had started off with the reaction number 1 for the preparation of aldehydes, and that too a very famous named reaction. Again, you need to note this down as well, right? So the named reaction which is known as, remember, Rosenmund reaction, right? So this is Rosenmund reaction, and firstly I would like to give some information about it. It is none other than the hydrogenation reaction, right? So first of all, this is the hydrogenation reaction. What do you mean by hydrogenation? That means you are reducing it, providing the hydrogens, right? That is what you are doing. And I am doing the hydrogenation of what? What particular substance I am doing? So the substance here taken in this particular Rosenmund reaction is the acid chlorides. What could be the other possible name of acid chlorides? Do you realize that? So the other possible name in the case of acid chlorides is none other than the acyl chloride. So I call it as acyl chloride as well. Clear? So these are some of the little things that you need to remember, because any of these names can be picked up and will come in your examination, and then you might be getting confused. So just to avoid this confusion, and the reaction, the entire reaction is although very simple, but just a matter of name will actually lead into confusion, will actually be leading you confused within the examination, and that will actually affect first of all your time, right? The time management in your examination. Second of all, you lose your confidence, right? And also you may lose marks in that particular reaction as well, right? So what you need to do, you need to focus whatever I am telling, whichever little thing I am telling, be it any kind of a name, right? So there may be a possibility that it comes it like that acid chloride hydrogenation will lead to the formation of so and so. So you must be knowing that what is the named reaction in that case, Rosenmund reaction, right? So that could be a possible way of asking, right, in the examination. So you must be very careful while these little things, while we are discussing these things, right? So this is the hydrogenation reaction, and what is hydrogenation? I am providing the hydrogens, and thereby I am using is, remember, Hubbard, right? What is that? H2 palladium on the surface of the catalyst, which has been chosen as the palladium over here, and the hydrogen, right? That is what we are doing, hydrogenation. So naturally I will be taking H2, right? So here I need the acid chlorides basically, and in this particular case if I say RCOCl plus, this is the general reaction I am talking about, RCOCl, I need to hydrogenate it, H2PD, right? And what I will be getting? RCHO. Is this right? So do you think that this particular reaction is right? This particular reaction basically is not right, because this is such a strong reducing agent, it will actually be leading to further reduction of this aldehyde. I am not stopping, the reaction is not stopped at just the aldehyde stage what I need, but at the alcoholic stage. So it further gets reduced to the alcoholic stage. Let me just write the equal number of carbons over here, right. So just in order to stop this particular process, that means the last one, because I do not need that, I just need is the formation of this aldehyde, right. So I need to poison the reaction. So as I asked you in the last session, what would be the poison which is taken up over here? So we already have discussed such kind of a poison before as well in many of the reactions. The poison used is barium sulfate, right, in the presence of sulfur, which acts as a poison to it. So this is the poison that we will be using, right. And what kind of a solvent is used over here? It is the boiling xylene, right, boiling xylene. That is what the solvent is used here, solvent, right. So again I am telling you must have the knowledge of each and everything which is used in the reaction. That is how you can remember it very well. Otherwise just mugging up would not lead to any kind of good results. That is tried and tested thing. Mugging up doesn't lead to success, but having a knowledge about it, having applied the logics over there will lead to better results, right. So here this has been taken as the poison. What is actually poison? It is stopping the reaction at aldehydic stage, right. And mind it that this particular reaction is only and only for the formation of aldehydes, right. I am not talking about the ketones here, we are discussing the preparation of aldehydes here, fine. So now in this particular reaction I hope everybody has got it, that I have taken is the acid chloride and I reduce it via H2PD, right. It is a very famous reagent, very famous reducing reagent, and I get is my desired aldehyde. Clear with the idea? Now if I talk about here, I am replacing this R with different groups. What will be the products formed? So let's just discuss that. So here I am writing down. So if I have got instead of this R, if I have got is let's say acyl chloride, fine, performing the reaction H2PD. Do not forget to mention BaSO4 and sulfur. If you do not mention BaSO4 and sulfur, the reaction is incomplete and you will not get marks at all, because the reaction here specifically, these reagents are very important and that is why it is known as the Rosenmund reaction, right. So I cannot just take up only one reagent and perform it. I need the complete set of reagents, the complete process. Fair? Very fair? So now here what will be the answer? I must add the poison here because I need to stop the reaction. RCHO, that is what I desire. Instead of this R, I will be replacing this R with methyl CH3CHO. What is the name of this particular compound which is formed? It's ethanol, right? And what is the name of this compound which has been taken? This is acyl chloride, right? Acyl chloride or acetyl chloride could be in the name. So this can also be called as acetyl chloride. What could be the other name? So the other name could be, I have got is eth, right? So ethanoyl chloride, right? So different possibilities, and I was talking about another kind of a reactant in the previous session. I had taken up was the benzoyl chloride. So again, in the case of aromatic acid chlorides, I can have a similar kind of a process happening. So I'll be getting what I desire, that means an aldehyde in that case as well. So it's the benzoyl chloride that I have taken. Fine. So you must be thinking that why I am representing this group attached with this position and not this particular position, but because here the benzene is actually same from all the sides if I look. So I can choose any of the sides, it's quite symmetric, right? So I can have any of the sides, it will be the same, right? So you can choose even this side for the representation, that is up to you completely, right? As per your convenience you have to do it. H2PD, again I need to poison it, because if I don't poison it, if I don't stop it, it will further get reduced to the alcohol. I do not want that. Fine. So it's BaSO4 sulfur. I've poisoned it, and what I get is, what is this known as? We already have discussed the name for this particular compound. Tell me two names of it, not just benzaldehyde. I've got is benzene carbaldehyde is also a possible name for it. So it's benzaldehyde or benzene carbaldehyde, right? So that is also a possible name for this compound. Clear with the idea? Now let me just discuss one thing with you. Will I be able to prepare here in this particular category if I say that I need to prepare is the formaldehyde? Will I be able to prepare? So it's a very important question over here. Can we prepare formaldehyde via Rosenmund reaction? Think about it. Via Rosenmund reaction. Is it? So you must be thinking, yes, we can. Or some of you might be thinking that I am asking this question, so that's why the reaction will be, the answer will be negative in this case. Definitely yes. That is so obvious. That is why I have asked this question with you, right? But why is this so? Here I am saying that I cannot prepare formaldehyde from this particular reaction, right? You need to find out the reason for this, right? So you must be thinking, some of you must be thinking, yes, we can prepare it, we can prepare the formaldehyde. I just need is this, right? What is this? The name for this compound is, write it down, it's formal chloride, right? So this is formal chloride, and what we see over here is this formal chloride on H2PD, again I am reducing, poisoning it even, and what do I get here is HCHO. Definitely this could be a possibility, but I am saying that this is not the possibility. I cannot make this reaction happen. Why is that so? The thing is, the formal chloride that I have taken over here, it is quite unstable at room temperature. Even if I take this compound, I start with the reaction process, then only it will disintegrate, right? It will degrade. It will not remain stable at the room temperature, it will just dissociate, right? I cannot have my entire compound within my reaction mixture. I cannot have that, right? Because this is unstable compound. It does not remain in this particular state. So how it is going to be giving my desired product? That is so obvious, right? So that is why, due to the instability of this formal chloride at the room temperature, I cannot have my formaldehyde formed via this particular process. Clear? So let me just write the reason here. Formal chloride is unstable at room temperature. So due to its instability, I cannot expect from formal chloride it is not at all a reliable compound actually. It will not be giving my desired product. Fine. So, I cannot apply the Rosenmund reaction in this case. Clear with the idea? So, that was it under the category of Rosenmund reaction. I hope everybody is clear with the idea. Quite an important process, mark this as important. Fine. Let us now talk about another kind of a reduction process that is known as stiffen reduction. Stiffen reduction. Stiffen reduction or stiffen reaction, it's one and the same thing. So, basically it's a reduction process, that is why I am calling it as a reduction, stiffen reduction, right. Stiffen, again the name of the scientist which was involved in this particular reaction. Not in the reaction mixture he was involved, but yes, he discovered this process, this entire process, and quite an important process although it is, right. So, it's a reduction or reaction. Now, what does it involve first of all, right? So, the stiffen reduction is basically associated with the nitriles. What are nitriles? The nitriles are those which are having CN bond, right? Having this CN group attached. The alkyl group attached with the CN group will be known as the nitrile. First of all, we need that information, right? So, what happens in the reaction? Let us see. So, here I have got a nitrile. It gets reduced in here with the formation of a very special compound, very special entity that is known as an imine, right. I get here is from the nitrile, what is this? Methyl nitrile, you can say, methyl nitrile. Is it or not? Is it methyl nitrile, ethyl nitrile? What is it? Think about it. Think a little about it. So, here this is methyl nitrile which will be then converted into imine. Now, what is imine? That is my question. So, the imine basically is CH3 CH double bond NH. That is what imine is, right? And you must be thinking that I haven't told any kind of a reagent which is involved over here. So, the reagent is actually very, very special over here, right? I like this particularly. I have got here the reagent is stannous chloride. I add in the stannous chloride is my HCl, right, the hydrochloric acid, and I get here is the hydrogen, the nascent hydrogen which is produced within the reaction mixture, which actually reduces it, reduces the compound, right. So, the stannous chloride actually is SnCl2, reducing the HCl into SnCl4, fine. And what I will be having here is the hydrogen which is produced, the nascent hydrogen which I am concerned with, fine. Nascent hydrogen, right. This is used for the reduction process here, right. So, this particular imine actually is a sort of a complex, right, with the, it bonds with the, associated with the HCl molecule, fine. This is the intermediate state that I have. So, after that intermediate state, what I will be leading here is, after the intermediate state, there is boiling water. That means I am performing the hydrolysis basically, and after this hydrolysis, I get is CH3CHO, this is what I desire, right. So, I hope everybody has got this entire process, quite an important process. This is imine, right, And just for your information, I am telling this imine species is actually has the tendency to tautomerize, right? So it has got the tendency of tautomerize. Remember tautomerization, right? We already have discussed in the 11th standard. So basically this imine is involved in the tautomerization process and it is forming enamine. Just for information, not included in the syllabus, right? So that is how this imine is. Tautomerize, let me just write here, tautomerize, fine. Now, this is the entire process. I hope everybody has got this process. So, what I am going to do is, I am giving you one example. So, instead of this particular compound, if I talk about I have taken as this, right, and I need is my product, my desired product as per the reagents used over here. Can you do that? So just take some time and try to find out the answer in here. So are you able to find the product for this particular compound? Now as I was asking you something, fine, before moving on to the answer to this particular question, I asked you what is this? Methyl nitrile? I am saying this is methyl nitrile. First of all, this methyl is not correct. It should be methane nitrile or something. But again, it is incorrect, right? So I was asking you that figure it out, will it be methyl or ethyl? What is the answer in here? So if you consider here, I have got 2 carbons, right? So 2 carbon means what? I have got eth, right? So there is no such kind of a compound as methyl nitrile. First of all, there is no such kind of a compound as methane nitrile, right? Only and only the name for this compound which is possible is ethane nitrile, right? So that is what the name for this compound is, ethane nitrile. And here, what is name for this compound? 1, 2, 3 carbons, again it's propane nitrile, right? Can you tell me another possible name, another common name for this compound? Think about it. So this is propane nitrile, right? So that is propane nitrile. Again, if I try to perform my reaction, so it's SnCl2 in the presence of what? HCl, right? That is what we have taken here, and which produces the hydrogen. I have written each and everything over the arrow itself, fine, that does not matter. Next thing, the next is I need my imine complex which is formed. So it is something like this, it's 1, 2, 3, 4, right? CH2, CH double bond, NH dot HCl. Even if you don't write this dot HCl, then also it is correct, right? It does not matter actually. Next thing, this is the imine which is formed. You need to mention it, and again the boiling water. Here basically this process is hydrolysis, right? So this process is basically hydrolysis, and again if I move on from the imine to my hydrolysis process, that is I am taking up the boiling water, or even I can mention as H3O positive, that is also correct, fine. Whenever we talk about hydrolysis, I can have this H3O positive as well, this will also do, fine, even if you do not remember the exact reagent which is used for the hydrolysis. So you can write this as, this will be perfectly fine, no marks will be cut in the examination. So finally what do I get? 1, 2, 3, 3 carbon atoms, and it's the name for this particular compound you need to tell me out. What is the name? It's propionaldehyde, one name. Propanaldehyde. That is one name I have. What could be the second possibility? It's propanol, right? It is propanol. Clear? So I was asking you something, right? What is that something basically? I asked something about this particular name, right? So have you thought about it? That what could be a possible name for this particular compound? I need the common name for it. So if you see here, I have got is 2 carbon atoms. So I can call it as aceto, right? So it could be acetonitrile, and that is what a very famous name for this compound is. There would be very less chances if I use ethane nitrile, but in most of the books you will find the answer, the name for this compound as the acetonitrile. Clear with the idea? So that was it under the category of stiffen reduction. I hope everybody is clear with the idea. Mark it out as important, right? You need to mark this out as important, quite an important reaction. Can be asked in the exam. Fine? So can you tell me, I have got this reduction process, right? Can I have any kind of an alternative to this reaction? That means in just one single reagent, not just these 2 steps, but in just one step, one single reagent, I get my answer. Is there any kind of a process, is there any kind of a reagent which is suitable for that? What is that? So what you need to do is, you need to find out the alternative to this particular reaction, right? I need an alternative reagent for it. So you need to find that out, think about it a little bit. If you are not able to find it out, Google it, go and search in your books. I'll be discussing the answers and the rest of the reactions in the next session. Have a very good day.